loops, and again we'll use the IPython blocks for illustration. So while loops are the most general type of loop in Python and are nearly essentially identical to while loops in other languages. So the way it works is we're going to, while a condition is true, we're going to execute the block of code defined with the while loop. So to start with, while loops can be made to function similar to for loops, only more verbose. So here's a while loop where we're going to print all the numbers between 0 and 10. So just like we'd expect with a for loop, but you can see we've got a lot of extra stuff here. So first off, we have to initialize a variable I, and we're setting it equal to 0. We do our condition here to test whether I is less than 10. If it is, then we define this block of code where we print I, and then we have to increment the value of I. In this case, we're adding 1 to I, and then going up here and repeating the test. Let's just contrast that to for I in range 10, print I. So in this case, you can see our while loop takes essentially twice as many lines. We can nest while loops, and of course we can also nest for loops. But let's look at this with the block grid. So I'm going to define again a 10 by 10 block grid. And here I have two nested while loops. And what I'm doing is I'm using one while loop to iterate across the width of the grid, and another while loop to iterate across the height of the grid. And again, I initialize my counter, this would be referred to as a counter variable. So I initialize I equal to 0 that I'm going to use to iterate across the width. And then for every time I'm in the while loop, I have to initialize for every iteration of the I, the width iteration, I initialize j, which I'm going to use for iterating across my height, and then I have the block of code defined for the height iteration. In this case, I'm just exploring different ways we can ask questions about our numbers. And if the condition's true, then I'm changing the color of that block, and we'll see what it looks like. Now, after I ask my question and take my action, I need to increment the value of j that I'm using for my iteration, and then when I finish the while loop for height, then I need to increment the I variable that I'm using for iteration across the width. So let's look at this. So in this case, what I have right now is I'm asking is I modulus 2 equal to j modulus 2? Meaning either that this value can be either 0 or 1, and this value can be 0 or 1. And as long as they're equal, either they're both 0 or they're both 1, then I'm changing to draw a red where I previously had a green. Now, we can do some other explorations here. We can ask whether I is divisible by 0 or j is divisible by 0. We can see what that looks like. In this case, let's see if this is doing, if I modulus 2 is equal to 0, so, or j modulus 2 is equal to 0, is drawing us the red. Okay, so here we have, every even row is drawn red, so we got 0, 2, 4, 6, 8, and every 0th column, second column, 4th column, is drawn as red, and the rest retains the original green of the original image, which I set to be equal to the value for phthalo green. Of course, here we're incrementing j by 1. We could increment the variables by a different value, and then we're not filling in as many points. This gets us back to our checkerboard if I increment by 1. So again, this is just something that you can look at changing the condition that we're asking the question about, of whether we're going to redraw the color, or you can change the characteristics of the iteration to see what happens. So let's see, we can just go to maybe a larger size, do 32 by 32. There's our grid, and as it gets larger, maybe we can just ask some more interesting questions about it. But it's a tool to allow you to play with the whiles and the fors and the ifs to get a more concrete feeling of what's going on with the code. So I could put in we could first off ask if they're equal to 0. We could ask if this is equal to 0. If they're both equal to 0, then we could draw the red. Else if we could ask if they're both have a remainder of 1, then, oops, I'm missing that. I could draw in a different color, which we could say here. So again, just an opportunity for experimental learning on the characteristics of these code blocks. All right. So while loops may execute anywhere between 0 and an infinite number of times. So we'll have 0 iterations of a loop when the initial test that we're asking evaluates as false, and infinity when the condition we're asking about at the top of the while loop always evaluates as true. So if we are in an infinite loop, well, out of any loop, let me just change this to say loops can be broken out of with a break statement. And let's just add here about infinite loops. That we will often get infinite loops by accident, but you can actually make use of infinite loops in conjunction with a break statement to make a valuable code blocks. Well, how do we end up with infinite loops on accident? It comes back to, let's go up to our simplest case. You see here in the while loop, we have to remember to explicitly increment our counter. In the for loop, because we're iterating over this range, that increment is being taken care of for us. But let's see if I dare do this. If I comment out this line, then you see we just end up with an infinite loop, which I'm probably going to regret having demonstrated that. See if I can interrupt my kernel.